So we're going to look in this section again at cofunction identities. Although we have already addressed cofunction identities in a previous chapter, we look at them one more time because cofunction identities, these cofunction identities listed here, can actually be derived using the sum and difference identity for cosine as well as a couple of other identities. So here we have them listed for you in this box. Notice that each of these cofunction identities are dealing with a degree measurement, the identities that are listed here. So if I'm talking about 90 degrees or so on, that's what these identities are listing for you. But remember that if instead of talking about a degree measurement, I want to talk about radian measure, all I have to do is replace 90 with its radian equivalent, which is pi over 2, and the formulas or the identities work the same. So these are the same identities whether we're talking about degree measurement or radian measure, but these are the identities for them. Now, what does a cofunction identity tell us? These tell us about a trig function that maybe has an acute angle, that it's equal to the cofunction of its complement. What does that mean? In other words, if I were looking at the tangent of 87, 87 is an acute angle, and I can rewrite that in terms of its cofunction by using the complementary angles, okay, which would be 90 minus 87 or 3. Okay, so 3 and 87 are complementary angles to each other, and that's how we would rewrite the tangent of 87 in terms of its cofunction. Okay, so it's really just allowing us to rewrite, for whatever reason we may want, an angle in terms of its cofunction. So let's get into an example here and apply these cofunction identities to a couple of examples. Here I have 4 examples that I'm going to work for you. The very first one says I want to find out what theta is if I know the secant of that angle is equal to the cosecant of 62. Well, first you want to recognize that secant and cosecant are actually cofunctions of each other, and the cofunction identity that I could use says the secant of theta is equal to the cosecant of 90 minus theta. Now I chose this form of the cofunction identity because what I'm really wanting to do is replace the left-hand side and rewrite it in terms of the same trig function. So if I already know what the angle is for a cosecant angle, then I want to rewrite the left-hand side in terms of cosecant as well. So we're going to replace the left-hand side, which says secant theta, with cosecant of 90 minus theta, which is equal to the right-hand side of the cosecant of 62. What that says is if I know that I take the cosecant of some angle, then that has to be equal to the cosecant of the same angle. So we are making an equivalent statement between these two angle measurements that we can then set equal to each other and solve. So in other words, we're going to take out the angle, which is 90 minus theta, and we're going to set that equal to the angle on the other side and then solve. So I am going to add theta to the right hand side and subtract 62 to the left hand side, and I find out that theta is equal to 28. Okay, so that's applying the cofunction identity using degree measure. Let's do the same thing, only in this example let's do it using radian measure. So cosine and sine are cofunctions of each other, and I already know the angle for the sine function, so I'm going to rewrite the left-hand side in terms of sine. In other words, the cosine of theta is equal to the sine of pi over 2 minus theta. Now remember, because I'm dealing in radian measure, I don't use 90 degrees, I use its radian equivalent, which is pi over 2. So I'm going to replace the left-hand side with the sine of pi over 2 minus theta is equal to 7 pi sine of 7 pi over 6. Again, the reason I want to do that is because I want to put on both sides of the equation the same trig function. And if I already know sine, then I'm going to rewrite the left-hand side in terms of sine as well. So we take the angle, which is pi over 2 minus theta, set it equal to the right-hand side's angle, which is 7 pi over 6, and then subtract. You can do this pretty easily when you're doing your fractions on your graphing calculator, but if I were to add theta again to the right-hand side and subtract 7 pi over 6 to the left-hand side, I end up with negative 2 pi over 3, and that's what theta would be. Okay, we've got two more examples we're going to work, and they're just a little bit more detailed as far as using the cofunction identities are concerned. So it's the same process. Here I'm looking at this example where I'm looking for the tangent of theta when the cotangent is 45 plus 2 theta. So I'm going to write the left-hand side using the cofunction identity that says tan theta is cotangent of 90 minus theta. So I'm going to rewrite the left-hand side using this portion of the identity. So cotangent of 90 minus theta is equal to the right-hand side, which was already cotangent 45 plus 2 theta. And now we just pull out the two angles and set them equal to each other. 90 minus theta is 45 plus 2 theta. Gather our thetas up over here on the right hand side, so that's 3 theta. Subtract 45 to the left and I get 45. Divide both sides by 3 and you find out theta is equal to 15 degrees. Okay, so that's just a little bit more involved. The last example that we're going to work, again, it's the same exact process that we've done before, where we're going to turn one side of the equation, or we're going to rewrite one side of the equation in terms of the other using the cofunction identities. Now there's two ways to do this. I chose to rewrite the right-hand side using the identity that says the sine of theta is equal to the cosine of 90 minus theta. So if on the left-hand side I have the sine of the angle, okay, sine of the angle, then I'm going to rewrite that saying that that's the cosine of the angle, which is 3 theta minus 15. Oops, sorry. It's the cosine of 90 minus the angle, which is 3 theta minus 15. And that's equal to the right-hand side, which is the cosine of the angle theta plus 25. The important step here is that recognizing that the identity says if I take the sine of some angle, that's equal to the cosine of 90 minus that angle. Understand that this is really just an angle that we replace theta with here. So it follows the same properties of 90 minus an angle, which is equal to cosine of theta plus 25. So we're going to take this portion out and we have 90, and I'm going to distribute minus 3 theta plus 15 is equal to the right hand side, which is theta plus 25. So I'm going to collect my like terms over here and I get 105 minus 3 theta is theta plus 25. Let's gather our thetas on the right and our numbers on the left. Okay, so I get 80 is equal to 4 theta, or theta is equal to 20. So the last example was probably the most complicated because I had these expressions on both sides. It would not have been incorrect if you chose instead to rewrite this using the identity that says the cosine of theta is equal to the sine of 90 minus theta. The process would have been exactly the same, except instead of substituting into the right-hand side of the equation, we would have substituted into the left-hand side and solved it that way. So two ways to be able to do that because we have two forms of the identity that we can use.